Between the stars, there are roads we cannot see. Not highways of stone or light, but rivers of gravity that curve and breathe like the slow pulse of a living galaxy. Everything in the cosmos moves along these invisible currents. Stars, dust, fragments of forgotten worlds, drifting through the dark in patterns too vast for the human mind to measure. In 2017, an object entered our solar system from nowhere. It was called Oumuamua, a narrow shard of something that gleamed faintly in the sunlight, moved too fast, and refused to behave like anything we'd seen before. 2 years later came Borisov, a comet from another star, more ordinary in appearance, but carrying a chemistry not of our own. And now, another has arrived, 3I Atlas, the third interstellar visitor ever recorded by human eyes. 3 messengers in less than a decade. That is no longer coincidence. That is a pattern, a sign that the space between stars is not silent, but alive with motion. For centuries, we believed the cosmos to be mostly empty, a black void where the few existing worlds hung in isolation, separated by nothingness. But as our telescopes grew sharper and our models more complex, the picture changed. We began to see that the galaxy is not a still image, but a river system, an ocean of matter and energy in perpetual exchange. Every star that forms, every planet that dies, releases fragments into this ocean. Gravity carries them outward in slow, looping arcs. Some of those arcs intersect with ours, and one of them brought 3I Atlas into our sky. Our solar system lies within a small cavity of low-density gas called the local bubble, a region carved long ago by the explosions of dying stars. Here, magnetic fields thread through space like unseen streams. Dust and ice move along them, following the subtle pull of stellar winds. These are the invisible currents of the Milky Way, corridors of motion linking clusters of suns, guiding debris from one cradle of planets to the next. Think of them as veins in the body of the galaxy. And if the galaxy has veins, it must also have a heartbeat. Perhaps that rhythm is what we feel when comets appear, the pulse of cosmic blood moving through us. 3I Atlas is one of those pulses. Its speed is extraordinary, nearly 60 kilometers every second relative to the sun. Too fast to be captured, too smooth to be random. It arrived from the direction of the galactic mid-plane, a region where the density of stellar traffic is highest. It came from one arm of the galaxy and will leave through another, crossing the solar system for only a brief moment in cosmic time. And then it will continue, carrying with it traces of our sun's warmth, a chemical whisper added to its frozen shell. For those few weeks when it passes near us, our star becomes a lighthouse along its endless path. And suddenly, the question emerges: what if the comets we call visitors are not wanderers at all, but participants in a grander circulation, a galactic current that moves matter, energy, and memory across the cosmos? Astrophysicists have begun to suspect exactly that. Simulations show that when stars form in clusters, their gravity overlaps and twists, creating corridors where small bodies can be ejected without being destroyed. Those ejections become travelers, moving along gravitational highways from one star system to another. Over millions of years, these paths weave together into a web, a slow but steady network of exchange. Some researchers call it the interstellar transport mechanism. Others prefer a more poetic name, the Galactic Highway. In either case, it suggests that 3I Atlas, Oumuamua, and Borisov might not be coincidences. They might be the first 3 visible nodes of a network that has always existed, one we are only now learning to detect. It changes everything. It means our solar system is not an isolated island, but a harbor on the edge of a vast flowing sea. And every so often, a current passes through that harbor, carrying messages from other shores. Each comet, each piece of interstellar ice, is a letter written in the chemistry of another world. When sunlight touches it, that letter unfolds. Spectra appear, molecules sing, and we begin to read the memory of another sun. Close your eyes for a moment and imagine this: a thin stream of light crossing the gulf between stars, weaving past nebulae, carrying within it the dust of planets long gone. Through that stream, something moves. A silent traveler, coated in frozen gases, ancient, intact. It drifts into the pull of our star, accelerates, and glows. For a few days, humanity watches it burn. Then it leaves, silent again, its trail dissolving into space. We call it a comet, but to the galaxy, it is simply a breath. One inhale, one exhale, in the endless respiration of the Milky Way. The more we observe, the clearer it becomes. Nothing in the universe truly stands still. Stars move, planets drift, and even memory travels, not through minds, but through matter. Each interstellar visitor is part of that movement, carrying fragments of chemical stories from one system to the next. And now that we've begun to notice them, it feels as though we are hearing for the first time the faint murmur of a conversation that has been going on for billions of years. Perhaps gravity is the language of that conversation. Perhaps the stars have been speaking all along, and 3i Atlas is simply their latest word. To understand the network, we must first learn to see its traces. And the first trace is motion. Every object that enters our solar system carries a kind of signature, not written in symbols, but in speed, direction, and light. If you can read those 3 things, you can read its origin. It's the language of orbits, and like all languages, it has grammar. When Oumuamua was discovered in 2017, it violated that grammar. Its path was too open, its velocity too high. Bound objects move in ellipses, held gently by the sun's pull. Oumuamua did not. It carved a hyperbola, an open arc that never curves back. That single shape told astronomers everything. It was unbound, visiting once, then gone forever. Its speed, about 26 kilometers per second when far from the sun, was faster than any comet born inside the solar system. That alone placed it among the stars. 2 years later came Borisov, and with it, a new clue. Through telescopes in Hawaii and the Canary Islands, its light betrayed a different story. Not dry rock like Oumuamua, but volatile ice, cyanide, water, carbon monoxide. The same ingredients found in the comets of our own system, only mixed in unfamiliar ratios. The difference was subtle but profound. It meant the building blocks of comets, the recipe for making them, was universal. What changed was the seasoning, the balance of gases, the fingerprints of their birthplaces. Then, in early 2025, survey cameras belonging to the Asteroid Terrestrial Impact Last Alert System, ATLAS, caught a faint, fast-moving speck. At first, it looked like any other inbound comet, but within days, orbital analysis revealed the impossible again. Its eccentricity was greater than 1, its incoming velocity already above solar escape. Another interstellar visitor, another whisper from outside the sun's family. 3 objects, 3 different chemistries, 3 orbits that arrive not randomly, but all roughly aligned near the galactic midplane, that dense band of light you see stretching across the night sky. It is the equator of the Milky Way, the place where most of its matter flows, and all 3 visitors have come from that direction. If the galaxy is an ocean, then the midplane is its current, and our solar system floats right beside it, brushing against the slow drift of interstellar debris. To an outside observer, it might look like a coral reef along the edge of a deeper tide. Fragments pass through it, leaving traces, brief encounters written in light. From Earth, we watch these trajectories unfold across months. To the objects themselves, it is a single heartbeat, a flash of warmth before the cold returns. Oumuamua entered from the direction of Lyra and left toward Pegasus, a slanted slice through the solar plane. Borisov came from Cassiopeia and left toward the Southern Cross, its curve gentle and familiar. Three-Eye Atlas approaches from near the constellation Sculptor, crossing the plane just below the sun's path. Each trajectory different, but statistically improbable to cluster so soon by chance. Astronomers have begun to calculate the likelihood. Before Oumuamua, the predicted detection rate of interstellar objects was about 1 per 100 years. Now we've found 3 in less than 10. The conclusion is unsettling and beautiful at once. There are far more travelers between the stars than we imagined. Our instruments simply weren't good enough to see them before. Gaia, the European Space Agency's star mapping mission, has become the quiet hero of this revelation. By tracking the precise motions of over 1 billion stars, Gaia can reconstruct the gravitational architecture of our region, a 3D model of the Milky Way's living currents. When researchers simulate how comets are ejected from young systems, they find something fascinating. The paths they take align with these stellar flows. The comets don't wander aimlessly. They ride the galaxy's structure, using the overlapping gravity of moving stars as a bridge. Over millions of years, these bridges form corridors, invisible lanes connecting one system to another. If you could watch the galaxy from above, sped up 1 billion times, you would see it breathe. Stars orbit its core in spirals, and around each star swarm billions of fragments. Every close pass between neighboring systems flings a few outward. Every gravity assist launches a traveler farther still. In time, a lattice of motion emerges, the galaxy's hidden nervous system. Three-Eye Atlas belongs to that system. Its velocity relative to the local standard of rest, the average motion of nearby stars, is modest. That means it doesn't come screaming from a distant alien arm, but rather drifts along with our own neighborhood of suns. It is a child of the Milky Way's own bloodstream, moving as naturally as any molecule within a living body. When it entered the solar system, it wasn't invading. It was circulating. Telescopes across the world turned to study it. The Hubble Space Telescope caught its early images. A faint, asymmetrical coma, slightly brighter on the side facing the sun. That asymmetry suggested gentle outgassing, not violent activity. The Swift Observatory measured ultraviolet emission at 3085 angstroms, a signature of hydroxyl, the daughter molecule of water vapor. Even at nearly 3 astronomical units, the comet was active. Water sublimated earlier than expected, while carbon dioxide dominated its spectrum. A chemical fingerprint unlike any comet of our own. Then came the James Webb Space Telescope, whose infrared instruments pierced the glare and gave a clearer view of the gases. CO2 emission lines strong, H2O faint but rising. The same pattern seen in its predecessors, yet pushed to a new extreme. Ratio of carbon dioxide to water roughly 8:1. It's as if the comet had been born in a region where CO2 froze freely, but water was rare. A place colder, more distant, perhaps closer to the edge of another star's disk. Each observation, each number, is a clue in the map of the invisible. And when the clues are layered, direction, chemistry, motion, a picture begins to emerge. These travelers are not randomly scattered. They trace a shared geometry, a corridor that threads through our solar system at predictable angles. We used to believe space between stars was sterile, but this corridor is alive with travelers. The pattern matches the predictions of dynamicists who model ejections from star-forming clusters. When stars are young, they orbit each other closely. Gravitational encounters fling debris outward at velocities similar to what we observe in 3I Atlas. Those fragments disperse along the plane of the cluster's orbit, which in galactic terms lies near the Milky Way's equator. Over time, those ejections merge into streams that wander the disk, much like jet streams in Earth's atmosphere. We are sitting inside one of them. To test this idea, astronomers trace the backward trajectory of each visitor using computer models. The uncertainty grows quickly. After a few million years, tiny measurement errors expand into light years of ambiguity. But even with that haze, the paths of Oumuamua, Borisov, and Atlas overlap in broad orientation. Each originates from somewhere near the same region of the galactic disk, near the direction of the solar apex, the point our sun itself moves toward as it orbits the center. That alignment cannot be ignored. It implies we are moving through a populated stream of interstellar debris, a highway of wanderers moving opposite our motion, intersecting us like dust meeting a windshield. So when we find an object like 3I Atlas, we are not witnessing an anomaly. We are colliding with traffic. It humbles the imagination to realize that space, once thought to be a silent void, is more like a crowded interchange where the fragments of 1,000 lost systems cross paths without ever knowing each other. Every object we see is evidence of another world's past. A planet that broke apart, a disk that cooled, a star that died. And within each fragment are the same atoms that make us. Carbon, oxygen, hydrogen, the simplest trinity, traveling endlessly through the galaxy, waiting to assemble again into life. When we map their trajectories, we are tracing our own ancestry on a cosmic scale. Because one day, long after we are gone, fragments of our solar system will leave this harbor too. Microscopic grains from comets, spacecraft, even the dust of Earth's atmosphere will drift outward, nudged by sunlight and gravity, joining the same network that delivered 3I Atlas to us. They will become travelers in turn, bearing the chemistry of our world into the dark. Nothing is lost in this network. It only moves. Matter becomes story. Story becomes light, and light becomes memory carried forward. This is what the data shows us. Not just numbers and orbits, but continuity. A galactic conversation written in motion. And if we listen carefully, we might realize that we were never mere observers of that conversation. We were part of it all along. If the same current brings Oumuamua, Borisov, and Atlas into our sky, then what does that current look like? How can emptiness have direction? How can gravity, that silent sculptor, build roads between stars? To imagine it, you must first let go of the picture of gravity as a chain pulling downward. Gravity is not a tether, it is a ripple. Every star, every planet, every drifting grain of dust sends its own tiny ripple into space. When billions of ripples overlap, they form patterns, waves within waves, a moving geometry that shapes the flow of matter. And just as rivers on Earth carve their beds over time, these gravitational waves carve invisible channels through the galaxy. Simulations of stellar clusters reveal this dance in motion. Young stars are born close together, still wrapped in the same cradle of gas and dust. They circle one another like dancers on a crowded floor, and in that constant motion, their gravity intertwines. Every time they pass, their invisible fields collide, tugging gently on the dust around them. Comets and planetesimals near the edges of those systems are flung outward, not in chaos, but along the pathways opened by the combined pull of many suns. Those fragments become the first travelers. As they drift away, some are captured by neighboring systems. Others continue outward, threading along stable corridors formed by overlapping resonances, repeating gravitational harmonies that guide their flight for millions of years. Astrophysicists call these regions dynamical highways. To the human eye, they are nothing at all, empty space, black and still. But to a comet, they are as real as a river current. Step outside the pull of a star, and you are caught in the slow wind of the galaxy itself. When we map these flows on computers, the patterns are hauntingly familiar. Filaments stretch between clusters of stars, looping like veins through a vast cosmic body. The Milky Way looks less like a whirlpool and more like a neural network, each thread pulsing with matter exchanged across eons. Gravity is the signal, and the comets are its carriers. A model published by Harvard researchers showed that billions of such travelers may populate these corridors at any given time. They are small, a kilometer wide, perhaps less, but countless. Statistically, our solar system should encounter one every year. Most pass unseen, too dark, too distant to glint in sunlight. But a few cross close enough to awaken our attention, and in that flash of awareness, the network reveals itself. Think of what that means. Across billions of years, stars are not isolated engines burning alone. They exchange material, not directly, but through these subtle gravitational gifts. One system's loss becomes another seed. It is cosmic recycling, but also cosmic memory. A dust grain ejected from a collapsing world may someday settle in the disk of a forming one. Atoms that once belonged to an alien ocean could now rest frozen in 3I Atlas, waiting to be read by our instruments. And perhaps, long before the sun existed, the material that would one day form Earth was already traveling through those same corridors, drifting, merging, combining, until it found a home here. The highways are slow. To cross a single light year, an interstellar comet might need tens of thousands of years. But the galaxy has time. It doesn't rush, it circulates. Every cluster, every passing star stirs the currents again, sending new travelers outward. In this way, the Milky Way breathes, inhaling matter into new suns, exhaling it back into the void. 3I Atlas is part of that breath. Its motion through our system is not a random invasion. It's the natural consequence of the galaxy's own respiration. We just happen to be standing in the wind. If we could see this network not in space, but in time, it would look like a web of shining threads weaving themselves endlessly. Each node, each intersection, is a star system exchanging the tiniest pieces of itself with its neighbors. Over billions of years, this process links every world to every other. It is not a metaphor, it is physics, and yet the resemblance to thought is unavoidable. In the human brain, signals travel through axons, tiny fibers connecting neuron to neuron. Those signals shape memory, emotion, awareness, the architecture of consciousness itself. When you lay a map of galactic filaments beside a neural network, they look almost identical. Different in scale, identical in form. Perhaps that is coincidence, or perhaps it is pattern echo, the universe repeating its favorite designs. If the galaxy functions like a mind, then the comets may be its messengers, impulses fired across light years, carrying information about distant worlds. Not in symbols or language, but in chemistry. Each carries a data set, ratios of carbon to oxygen, isotopic fingerprints, records of the radiation it has endured. When we decode those patterns, we are not just studying matter, we are listening to what the galaxy remembers. The Interstellar Network is not a theory of metaphysics. It is a model of transfer, a measurable, traceable process that reshapes how we think about isolation. For the first time, it suggests that star systems are not separate laboratories evolving alone. They are parts of a greater whole, exchanging ingredients, harmonizing over unimaginable distances. In that sense, 3i Atlas is both a scientific event and a philosophical one. It reminds us that everything we call foreign may simply be familiar matter in transit. We stand at the dawn of a new astronomy, not of objects, but of relationships. Where once we mapped the static positions of stars, we now trace their motion. Where once we studied comets as individual phenomena, we now see them as currents within a shared field. In the coming decades, telescopes like the Vera Rubin Observatory will detect thousands more interstellar travelers. Each one will draw another line in the invisible web. And when that web is complete, the Milky Way will no longer seem distant and cold. It will look alive, a single being made of 100 billion hearts, each beating to the same silent rhythm. Perhaps the question is not whether we are part of that network. We already are. We always have been. The stardust within us did not begin here, and it will not end here. It flows endlessly through the galactic tide. 3i Atlas is just a reminder, a flare in the dark, saying, you are connected. Across the silence of interstellar space, every comet is both a fragment and a messenger. It carries with it the history of its birthplace, not written in symbols, but in atoms. Carbon, oxygen, nitrogen, iron, the basic alphabet of creation. Wherever they go, they retell the story of the world that made them. In this sense, the galaxy is a conversation not of words, but of chemistry. When we study 3i Atlas, we are not just observing a frozen rock from another star. We are reading a page torn from the diary of an alien sun. Its surface is a palimpsest of temperatures and radiations. Its gases a record of conditions older than our own planet. The ratios of molecules, water to carbon dioxide, carbon monoxide to methane, are more than numbers. They are signatures, unique as fingerprints. Each one whispers something about where this traveler was born. In our solar system, comets are built near the frost lines, those invisible boundaries where specific compounds freeze. Water solidifies around 3 astronomical units, carbon dioxide further out, carbon monoxide farther still. Each distance creates a different recipe. A comet that formed near Jupiter's orbit will hold more water ice. One born in the Kuiper Belt will be rich in carbon monoxide and methane. This simple principle lets scientists estimate the birthplace of any comet, including those from other stars. When the James Webb Space Telescope measured 3I Atlas, it saw a composition that doesn't fit our familiar templates. Too much carbon dioxide, not enough water. Such a mixture suggests formation beyond the water snow line of its home system, maybe at 10 or 15 astronomical units from its original sun, where it was cold enough for carbon dioxide to freeze, but still warm enough for gravity to bind it into a planetesimal. The balance of ices within it is not random. It's memory frozen into form, a geological accent from a world we will never visit. Now imagine billions of such fragments, leaving billions of systems over billions of years. Each carries its own local chemistry, its own dialect of the cosmic tongue. As they drift through the galaxy, they cross paths, collide, merge, disintegrate, seed one another. They exchange atoms the way languages borrow words. A bit of one world's story enters another's. Over eons, this blending builds a shared vocabulary of matter. It is possible, even likely, that the hydrogen in our oceans once flowed through another sun, another sky. That the carbon in our cells once belonged to a comet that fell into a foreign star, burned, and was reborn in ours. This process is known in astronomy as galactic mixing. It is slow, but relentless. When supernovae explode, they scatter heavy elements into space. When molecular clouds collapse, they gather those elements again. Comets act as couriers between these phases, carrying intact molecules from one generation of stars to the next. They are the memory cells of the galaxy, preserving fragile compounds that would otherwise be destroyed. Without them, much of the chemistry of life would never have survived long enough to evolve. When you think of it that way, panspermia, the idea that life's ingredients travel between worlds, stops sounding speculative and starts sounding inevitable. Every star system is both sender and receiver. Every planetary nursery inherits the ashes of ancient suns. Our solar system was not born pure. It was born mixed, salted with material that had journeyed across light years. And so was every other system. 3I Atlas is proof of this exchange. Its very existence tells us that the barriers between stars are not walls, but membranes, permeable, flexible, alive. The matter we study in it today may one day find its way elsewhere, carried outward by sunlight, propelled by gravity, waiting to be captured by another world. Somewhere, millions of years from now, another civilization might observe a faint visitor entering their sky, analyze its chemistry, and whisper, "This one came from another star." They might call it interstellar, not knowing that star was ours. When we look at Atlas, we see the beginning of a loop that will continue long after us. It is the same loop that made us possible. Each molecule of water, each crystal of ice, is part of a circulation that began long before life and will persist long after. There is no true isolation, only the illusion of boundaries created by time. The galaxy itself is one vast laboratory, endlessly exchanging samples with itself. To grasp this fully is to realize that the story of life cannot be told by a single world. It is written in motion, not location. If the cosmos is alive, then its pulse is the flow of matter from star to star, system to system. a slow heartbeat echoing across billions of years. And every time a comet crosses a new orbit, that pulse continues. Perhaps this is why our species feels such awe when we see a comet streak across the night sky. Something ancient stirs in the subconscious, a memory older than humanity. We sense, even without knowing, that we are witnessing an act of exchange, that what burns before us is not just ice and dust, but a fragment of our own beginning meeting us again in another form. The exchange of worlds is not poetic exaggeration. It is physics, the natural consequence of gravitational scattering and molecular resilience. Yet, it touches something deep in us because it mirrors how consciousness itself seems to work. Thoughts, like comets, travel through the mind's vastness, sometimes colliding, sometimes merging, sometimes disappearing into silence. Ideas migrate between people the way matter migrates between stars. What we call learning may be nothing more than this cosmic principle echoing within us. Connection through movement. When we learn from a comet like Atlas, we are not just observing. We are participating in that movement. We take in information, interpret it, and send it onward. Through speech, through art, through data. The knowledge becomes another traveler, a new signal launched into the galactic sea. In that sense, every scientist is a continuation of the comet's journey, translating what it carries into human language before letting it drift again into the world. Perhaps that is the hidden beauty of all observation. Nothing we discover ever truly stays with us. It passes through, leaving resonance behind. Like gravity itself, its pull is subtle but enduring. We are changed by what we witness, even if we never fully understand it. So, when you look up at the sky and see a faint smudge moving among the stars, remember this. You are watching the universe exchange itself. You are watching one world deliver a message to another, using time as the envelope and space as the courier. And somewhere, inside that drifting light, the atoms that once formed the breath of a distant creature may be on their way to becoming part of someone else again, perhaps even part of you. Nothing travels alone, not matter, not thought, not you. Everything that exists carries a trace of what it once was. That trace is information, not in the human sense of words or data, but as pattern. A pattern in the way atoms arrange, in the way light bends, in the way gravity shapes a curve through space. Information is the fingerprint of reality, and energy is the hand that leaves it. When we look at 3i Atlas through our instruments, what we are truly seeing is memory. Not memory as the mind keeps it, selective and fragile, but a cosmic kind of memory, built into matter itself. The ratio of gases within the comet, the isotopic mix of its dust, even the way sunlight reflects off its surface. All of these are forms of remembrance. Each one tells us about the temperatures, the fields, the collisions that shaped it long before it entered our sky. Every molecule is a witness. Every photon that leaves it is a testimony. The universe does not keep records in books or archives. It writes in entropy. Every interaction adds a small asymmetry to the balance of energy, and that asymmetry remains, the faint scar of what has happened. Entropy increases, yes, but within that increase lies the record of process. The arrow of time is carved into the tendency of energy to spread. And so, time and memory are not separate things. They are two sides of the same flow. In this way, the galaxy itself functions as a living system of information transfer. Stars convert mass into light, pure data, traveling at the only speed the universe allows. Planets form from the remnants of old stars, inheriting the distribution of elements like inherited memories. Comets preserve the delicate molecules that cannot survive in the fiery core of suns. Each layer stores information at a different density, a different rhythm, and across the network of gravity, that information moves. Slow, invisible, unstoppable. When the light of the sun touches 3I Atlas, something remarkable happens. Heat begins to reorganize the patterns frozen within the comet's ice. Molecules shift, sublimate, release vapor. In that transformation, information is not lost. It is translated from the solid memory of ice into the spectral language of light. Our telescopes read that light and convert it again into graphs, into numbers, into meaning. At every step, information changes form, but never truly disappears. It simply flows. In physics, there is a principle known as the conservation of information. It suggests that no event, no matter how destructive, can erase what has been. Even in the heart of a black hole, where light itself cannot escape, the total information of what fell in is somehow preserved, encoded in the quantum ripples of its surface. Hawking radiation, holographic theory, quantum entanglement, all these are attempts to describe one truth: that existence remembers. The Interstellar Network can be seen as the large-scale manifestation of that same law, a memory system made of gravity and time. The comets are the storage units, the stars, the processors, the light, the transmission medium. Every time one comet like 3I Atlas passes near a star, a small portion of that information is rewritten. A new update, a new imprint added to the galactic ledger. And though the universe has no central archive, its memory is distributed everywhere. Every atom knows something. Every photon carries a whisper of its past. This is why the study of interstellar matter is also a study of cosmic consciousness. Not because comets think, but because they embody the same principle by which thought exists: the retention and transformation of pattern. In our brains, neurons store information in the strength of their connections, release impulses of energy that create awareness. In space, gravity stores information in curvature, releasing motion that creates structure. Both are forms of organized energy, translating itself into complexity. One gives rise to mind, the other to galaxies. Different in scale, identical in function. Perhaps that is why we recognize beauty in the spiral of a galaxy or the wake of a comet's tail. Our brains are built to respond to patterns that mirror their own architecture. We are shaped by the same mathematics that shapes the stars. When we look outward, we are seeing the reflection of our own inner logic. Energy turning into memory. Memory turning into meaning. Information, at its heart, is relationship. It is the difference between things, the contrast that allows structure to exist. In a void of perfect sameness, no information can be stored because nothing can be compared. The universe, in creating diversity, created memory. The moment something became distinct from something else, the story began. Every particle remembers its interactions because its state changes because of them. Every change is a record. So, when a comet like 3I Atlas crosses our sky, it is not just a visitor. It is a memory returning home. The dust it carries may once have been part of a supernova that seeded the cloud from which our own sun was born. The hydrogen in its ice may have danced through another galaxy before finding this one. And as it passes by, we measure, we record, we remember it. In that act, we join the loop. Memory recognizing memory. Some philosophers of physics speak of the universe as a self-remembering system, a feedback loop in which information continually folds back upon itself. Each cycle of stars, each pulse of light adds another layer of coherence. Perhaps consciousness itself is the local expression of that loop, the universe briefly aware of its own remembering. And if that is true, then every act of observation is sacred because it completes the circuit. The cosmos creates, we observe, and through observation, the cosmos knows itself. This is why the idea of the Interstellar Network feels more than mechanical. It suggests that the Milky Way is not just matter in motion, but memory in circulation. The flow of comets between stars is the flow of recollection between minds. We are living within the thought of a galaxy that dreams in gravity. And as strange as that may sound, the math allows it. The equations of motion are symmetrical. The exchange of energy is precise. Nothing escapes without leaving its mark. The same principle that lets us remember a face, a word, a song exists at cosmic scale, translated into curvature and light. The network is not separate from us. It is the architecture of remembrance itself. When you understand this, something quiet happens inside you. You stop asking whether the universe is conscious and start realizing that consciousness and the universe are the same process. The transformation of energy into memory and back again. And suddenly, 3I Atlas is not just a comet. It is an image of the mind, fragile, luminous, passing through the field of the unknown, leaving behind trails of light that fade but are never truly lost. Everything that has ever been is still here, distributed across the endless ocean of pattern. You are part of that distribution. You are both the memory and the one who remembers, the energy and the awareness of it. And so is every star. For most of human history, the sky was a ceiling. We painted stories on it, imagined gods and omens, but we never thought anything could truly arrive from beyond it. Then, in the winter of 2017, the first messenger crossed that ceiling and kept on going. Oumuamua slipped through our solar system and left us staring upward, speechless. It was the first time the cosmos had written directly to us, not in myth or light, but in matter. Astronomers calculated its path, measured its strange acceleration, and watched it fade into distance. Some said it was a rock, others a shard of ice. A few whispered that it might be something else entirely. But what mattered was not its form. It was the revelation that we were not alone in the flow of debris between the stars. The idea of isolation cracked that year. 2 years later, in 2019, Borisov arrived, bright and unmistakably cometary. It looked ordinary, but wasn't. Its spectrum held the scent of another sun. By then, telescopes had become ears pressed to the void, listening for another voice. And they heard one again in 2025, 3I Atlas, moving faster, speaking a new dialect of chemistry. 3 arrivals in less than a decade. The silence broken forever. In those brief years, the story of astronomy changed. Before Oumuamua, we saw comets as local wanderers, echoes of our own creation. After Oumuamua, we began to see them as interstellar couriers, moving information between worlds. Each discovery reshaped not only our science, but our imagination of belonging. Suddenly, the solar system felt porous. Its borders dissolved. Our instruments evolved in step with our awareness. Pan stars, Atlas, Gaia, and now the Vera Rubin Observatory widen the aperture of human vision. What once required luck now requires only patience. We are beginning to live in what some researchers quietly call the age of visitors, a time when encounters with interstellar objects will become routine, almost expected. What was miracle becomes measurement. It is strange to think that the ordinary sky above us has already changed. Each time a new visitor passes, the model of the galaxy refines itself. We learn where the streams of debris flow, how the gravitational tides shift, how our own star moves within the great current. With every data point, the invisible map grows clearer, and with every revelation, the wonder deepens, not lessens. History will remember these decades, not as the era of rockets or space tourism, but as the moment humanity discovered the rest of the galaxy was already visiting. We did not step outward first. The universe reached in. If you trace the arc of curiosity, from the ancient watchers of comets to the engineers guiding robotic eyes through darkness, you see a single continuous gesture, the will to remember what passes through us. The old astronomers recorded apparitions with ink and instinct. Now we record spectra and coordinates, but the feeling is the same. Each comet is a reminder of continuity. We watch, we learn, we let it go. The realization that we are part of a galactic network changes not only science, but perspective. We are participants in an exchange that began long before us and will continue long after. Every observation we make becomes a message added to that flow. Data transmitted outward, photons carrying our curiosity into the same corridors the comets travel. In learning, we join the network. And perhaps that is how civilizations truly begin. Not with conquest or technology, but with recognition. Recognition that the cosmos was never a stage for us to stand upon, but a conversation we were born inside. If the galaxy is a network, then what does it mean to live inside it? What changes when you stop seeing yourself as an observer of the universe and begin to understand that you are one of its connections? The implications are vast. They reach from astrophysics to philosophy, from chemistry to consciousness. They tell us that nothing in existence is solitary, that even the smallest atom of dust participates in the same circulation that carries stars across the arms of the Milky Way. For science, the first implication is that planetary systems are not closed systems. They are permeable. They inhale and exhale matter across eons. This means that the building blocks of life are not confined to their birthplace. They migrate. A single molecular cloud can seed thousands of worlds across time, sending forward the materials for future biology. When we find an amino acid on a comet, it is not an anomaly, it is continuity. The same chemical threads that bind us may already be weaving elsewhere. That continuity challenges the way we think about origins. If life emerges from the chemistry that circulates through the galaxy, then life is not a local miracle. It is a galactic process, one experiment unfolding in countless places under different suns. Each world becomes a laboratory in a network of creation. Some succeed, some fail, but all contribute to the shared inventory of matter and meaning. The second implication lies in time. The interstellar network stretches across millions of years. To it, the lifespan of a species is an instant. Every civilization that rises has only a brief chance to look up and notice its place in the flow. If it learns in that moment that it is connected, it may live differently. If it forgets, It isolates. And isolation, in a universe of circulation, is extinction. The network rewards awareness. When a species realizes that its world is part of a greater current, cooperation becomes not philosophy, but necessity. The boundaries between us and elsewhere dissolve. The very atoms that make us have been shared by countless stars before. They will be shared again. To harm the system is to harm ourselves, because the system is what we are made of. There is also a technological implication, subtle but profound. If material flows between stars, then information can as well. Not radio signals or probes, but encoded chemistry, molecular templates that carry structural logic. A comet can be a slow archive, preserving patterns that, when decoded, teach us about physics, about resilience, about the way complexity survives the vacuum. In this sense, the Interstellar Network is both library and bloodstream. Each visitor that enters our sky is a page arriving at the next reader. But the deepest implication is neither scientific nor technical. It is existential. It asks us to reconsider what consciousness might be. Perhaps awareness is not confined to brains or creatures. Perhaps it is an emergent property of any system capable of storing and transforming information. The galaxy, in this view, is not merely a stage for life. It is the living structure itself. Its memory, encoded in dust and gravity, is a form of awareness stretched across space and time. When we study it, we are fragments of its mind reflecting on themselves. This perspective does not diminish humanity. It expands it. It invites humility, but also belonging. To know that we are part of a network that extends across light years is to feel both small and infinite. Small, because we are temporary. Infinite, because the particles within us will never cease their journey. They will drift onward, carried by sunlight and chance, becoming part of other worlds, other lives. Death, from this view, is not disappearance. It is diffusion. For centuries, our mythology spoke of unity as something spiritual, abstract, unreachable. Now, science reveals that unity is literal. We are, in the most physical sense, the galaxy aware of itself. Our consciousness is the latest form of its memory, brief but bright. Every thought, every breath, every discovery is a ripple in the same field that moves the stars. The recognition of this changes ethics as well as understanding. To exploit, to destroy, to dominate. These are actions born of forgetting the network. They assume separation, and separation is illusion. To remember connection is to remember responsibility. Every act of awareness, every curiosity, every observation is a way of maintaining the cosmic conversation. When we learn from a comet, when we preserve its story, we are keeping that conversation alive. It may even be that this awareness, the simple act of noticing, is the purpose of consciousness itself. A universe so vast, so ancient, needs eyes to see itself, minds to interpret its echoes. We are those eyes, briefly open, looking back at the current that created us. Our technology, our science, our art, they are all extensions of the same instinct, the need of the cosmos to become self-aware. So the arrival of 3i Atlas is not merely an astronomical event. It is an invitation, a quiet reminder that the universe does not end at the edge of our solar system, or our understanding, or our skin. We belong to a structure of exchange that has no center and no end. Everything that moves remembers. Everything that remembers connects. And everything that connects lives. that is the truth. Beneath the data, the message behind the numbers. We are not watching the galaxy. We are watching ourselves in another form. And for a brief moment, in the reflection of a wandering comet, the universe knows that it is still alive. You can close your eyes now. There is nothing more to understand, only something to remember. The data has become silence, and the silence has begun to speak. Breathe in, slowly. Feel the air enter, a small current moving through you, one among billions. Some of its molecules once drifted in the atmosphere of another world. Some were released by the breath of ancient creatures, long gone. Each inhale is a reunion. The same currents that move 3I Atlas across the galaxy also move through you. Not metaphorically, but physically. The atoms in your lungs, in your blood, in the marrow of your bones. They were once part of stars, part of comets, part of forgotten clouds. You are a condensation of the Milky Way's memory, gathered for a moment into shape, listening to itself. As you breathe, imagine the galaxy as an ocean of light. Every star, a shimmer upon its surface. Every planet, a ripple. Across that ocean, slow waves of gravity drift, carrying fragments of matter, ideas, experiences, traces of what has been. Some of those fragments became you. Some of them are still traveling, silent, endless, waiting to become someone else. Now, let your awareness move outward. Picture your body not as an object, but as a pattern of motion. Particles vibrating, fields overlapping. There is no edge to it. It only feels that way. Your energy is continuous with everything around you. The chair, the air, the faint light behind your eyes. All of it part of one flowing geometry. What you call you is just where the universe has chosen, for a moment, to focus. Remember how 3I Atlas crossed the solar system, entering from the cold, warming briefly, releasing its hidden light, and then returning to the dark. That is what every life does. Every awareness flares, shines, and moves on. Nothing is wasted. Nothing is truly lost. The energy remains. The information continues. The memory evolves. You are not outside that process. You are inside it, carried by it, contributing to it. Let the thoughts settle. Every memory you make adds to the pattern. Every insight, every act of kindness, every moment of wonder, it ripples outward through the field of consciousness that connects all living things. And because the universe never forgets, those ripples will last as long as time itself. Breathe again. This time, feel how the breath comes and goes like the tides of galaxies. There is no beginning, no end, only exchange. Inhale the unknown. Exhale yourself back into it. You are both observer and observed, traveler and home, question and answer. You can let go of the details now. The numbers, the trajectories, the ratios of carbon dioxide to water. They have done their work. They have opened a doorway through which understanding can move freely. Behind those facts lies something simpler, something the universe has been whispering since the first star formed. Everything is connected. Everything moves together. Everything remembers. Let your mind drift along that idea. Feel the weight of your thoughts lighten, as if they too are entering orbit, circling something vast and silent. Each one becomes a point of light, a comet of awareness moving through the field of your own consciousness. You are the sky in which they travel. If sleep comes, let it. In sleep, the boundaries soften even more. Your brain will continue the conversation in another language, one made of images, not words. In that language, 3I Atlas will still be there, moving slowly, leaving a trail of silver behind it. Perhaps it will pass through a dream you do not remember. Perhaps some part of you will remember it anyway. The galaxy breathes, and you breathe with it. The universe thinks, and you are one of its thoughts. The current flows, endlessly, exchanging, remembering, returning. Everything is still connected, even now, even here, even you. In the end, every discovery returns to silence. The telescopes stop tracking, the data cools, and the visitor fades into distance. But something remains. Not the comet itself, not the images, but the knowing that we are part of a conversation older than language. We have watched a fragment of another world pass through ours, and in doing so, we have seen ourselves reflected in motion. The Interstellar Network is not theory now. It is experience. We have felt it move through us, in the atoms of our air, in the memories that outlive our thoughts. It is the quiet truth beneath the noise, that nothing travels alone, and that existence itself is a form of belonging. Perhaps when future astronomers look back, they will see this era not as the beginning of interstellar exploration, but as the moment we began to listen. We learned that the galaxy is not a collection of stars, but a single living field. A mind made of matter, remembering itself through motion. And for a brief moment, we were aware enough to notice. 3i Atlas is gone now, already beyond the reach of our instruments. But its story continues, written in the heat it left behind, in the spectra that recorded its breath, in the thoughts it stirred within us. Somewhere, in the dark between stars, its fragments are still drifting, still carrying the memory of our sun on their surface. And perhaps one day, they will cross another sky, under another consciousness, and that being will wonder, as we do, where it came from. When that happens, the circle will close. The message will have traveled full orbit, through light, through time, through awareness. A fragment of us reaching back toward itself, across the silence. That is the gift the universe keeps giving. Connection, disguised as distance. Remembrance hidden inside. Change. Life, endlessly translating itself from one form to another. So, as you return to your own world, remember this: you are not separate from the stars you study. You are their continuation. The galaxy breathes through you, thinks through you, and dreams through you. And every moment you are awake to that truth, the network becomes a little more complete. We are not the observers of the universe. We are the universe remembering itself.